Okay, let's go ahead and get ourselves started today. Today we want to go through and continue with this pushing some of the capabilities of Dynamo and the whole approach of kind of scripting languages to control elements in our Reddit models. And really kind of take it to even a higher level. We've been doing a lot of very kind of direct manipulations, so very simple things with programming language, adjusting parameters, instance parameters, and even be doing some type parameters with different types of objects, and thinking about how we can use math to control those a little bit. But then we're going to take it even further in terms of being able to start thinking about how to just control place and control the points and the curves that ultimately determine a lot of the geometry, and then use that to generate surfaces, which we can then subdivide and analyze and start using to go through and to kind of create some really interesting geometries, by driving it out of the programming interface. So we looked a little about the whole notion of like an attractor, which actually turns out to be kind of a very useful concept. We're going to keep on working with things like that as we start thinking about how we're interacting in the environment. One big thing is whether things either attract or repulse and our ability to respond to that. We're also going to take that into how we respond to the position of the sun, and think about not only the distance from things, but the angle relative to things, and how we would adjust things to go ahead and react smartly to where things are located right now. Let's kind of dive on in there. Here's what's going on. So for today's session, what I wanted to do is actually start out with, it's a file that's all about doing instance properties driven by a sine wave. And we kind of looked at it a little bit at the tail end last time. To follow along today, if you could please go to Coursework and download for yourself just the session 3 Dynamo examples.zip. You're once again going to find a whole bunch of little scripting files and Revit files just to kind of work along as we go. That guy on down, and let's use some files in there as a starting point. We'll be generating everything that's hanging around inside that file, but just a little useful parts in case you fall off along the way and you want to kind of catch back up to just open up a file and kind of keep on going with it. So if you pull that on down, what you will hopefully see is something like this, where we have just a bunch of different example files. And again, the way I'm trying to structure it is that we'll typically have a Revit file, so some sort of either a Revit or either a family or a project file that we can work with, as well as some Dynamo scripting files. And what I like to do is sort of give you the end point as well as a starting point, so that some of the primitives are in place, but you can kind of go through and build it up from there. Okay, so if you go ahead and open that up, what I want to start with is just example 3.1. That's that one we were looking at the tail end last time, which is just the whole notion of doing window instances, okay, and doing it mathematically. And this was actually sort of driven by, it was a project someone had worked on last year. CJ had the idea of, could you go through and have an undulating window form, something like that. We'll use that as a starting point for where we're going today. In terms of what we're looking at there, the basic script for what we're doing looks something like this. We just need to basically get some information about the Revit family instances that are out there. So as opposed to sort of placing instances, in this case, I place some instances in Revit and I'm going to get information about them. So you can do it two ways. You can either programmatically place things, which is pretty easy for most families. It turns out I did some playing around with the whole issue of placing windows in walls. It's a little bit harder. Posting things inside of other objects kind of adds a layer of complexity to all this. But if we have some things that are already placed, we can get information about them, figure out where their locations are, and then from that, just go through and try and do some calculations. In this case, what I did was we extracted some values for where the X and Y locations of all the windows were, and based on that information, went through and did a calculation, kind of a sine wave calculation based on the X values to go through and give me a base height, a sill height that I would apply to those windows, based on where they are on the x-axis. Okay. It's a pretty straightforward example, but let's use it as a starting point because it's sort of a useful one. Okay, so if you want to, go on over to example 3.1, open that up, and let's take a look at it and go from there. So in terms of all these instances being out there, again, these instances have been placed. I just placed those in Revit as a starting point. I did array them together, just kind of create a regular array of them. But that's not going to be all that important in just a minute, how they got here. The most important thing is that we just have these different these different families that have been placed. And within the families that have been placed, they actually have a fairly limited set of instance properties. They have the sill height and the head height, which are related to each other, by the height of the window. But the width of the window and the height of the window are actually type parameter right now. Okay, so as I go through and change the types, those things will change appropriately. Okay, but in this case, let me go ahead and stay back there. We're going to talk about doing something a little more interesting in terms of making those heights resizable in just a bit. Okay. But given that we already have these guys in here, the idea is what we want to do is just based on the distance from some location, go through and be able to kind of have some undulation in this. In this case, just by adjusting the instance property, the base height. Okay, we could also do that by adjusting the height of the windows, as opposed to, if we had that available as an instance parameter. We'll look at that in a second. But let's go through and open up Dynamo and just take a look at the finished script that I used, and we'll see if we can just unpack it a little bit. I kind of like to start out by looking at where we're going and then back off to it. So if you go on out there and grab inside the folder this, there it is, sine wave, and we'll start with the end point. Let me just open that up first to show you what that looks like. See if we can just unpack this a little bit and just understand the basic scripting and get a preview of some of the constructs we're going to be working with. Okay, so I'll start kind of over here on this side, and up front we're going to learn about selecting the family types. We did that in terms of placing things. In this case, we're selecting the family type, and again, those are just the types that are loaded into the project. So if you want to have one available, it's not there, you need to load it in the Revit project. And then diff family instances is sort of the exact opposite of placing or creating family instances. And we're going to take all the ones that match that type and pull together a list of those. Okay, so if you even go ahead and take a look at that right now, let's see if we can let me run this. You pull on down, and you'll see that at this point, we're getting a list of a whole bunch of different objects that are coming from based on whatever's mapped over here. Now, if we went through and changed that to something else, like the baluster or something like that, and ran that, you should find that that list is empty because there's just nothing that has been placed that matches that. Okay. So it's the list that's returned just really depends on matching the type that we're selecting over here. And what was it? The one that I did place was called fixed, I think 12 by 48. Let me run that. And you can see there's that list of objects. Okay, once we go through and grab that list, let's kind of unpack it a little bit. You can't really see much about the objects here. They just show up as a little list. Okay, but you can't actually see the values very much. What we can do is start pulling some information out. For example, we can, for each of these family instances, give its location, which give us some X, Y, Z coordinates. And that's what's happening up here at the top. So this list right here is, given that list of all those elements over here, let's pull out the X, Y, Z's. Yes?
Sorry, I got this one right there.
Okay. So what's happening is somehow downstream from where you are, it's not getting information that it needs. So probably what's happening is kind of starting up in here. The X's are not valid. Let's kind of figure out if we can figure out why that is. It's let's say if we pull down that list and see if there's any values in there. Yeah, there's something about it. It's not interesting. Let's see, kind of gonna come around and see if we can help you find it. Okay, so let's see if we can figure this out. Yep. No worries. It all starts with just this notion of, let's escape out of here, just let's see some things. Okay, the list is empty right now. So, because the list is empty, that means that the family instance locations is empty. So we're just going to back up the stream a little bit and see if we can figure out why. Okay, this list is empty, and it's because over here in this selection, we're looking at the 16 by 24 windows.
Yeah, I couldn't find the
Oh, no worries. Do you have the Revit file, the same Revit file open in the background?
yes.
Okay, so let's see if we can figure out what the difference is. Okay, so here we are.
And for some reason I have to minimize it.
Oh, no worries.
Oh.
Okay, so what is that? That says fixed 12 by 48. That is very, very strange. Why it's not finding them? Let's go ahead and find same issue. Let's see if we can fix it the other way. Okay, you know it's looking for 16 by 24s. Yeah, I'm not sure why it's not finding the 12 by 48 yet. That's yeah, it's some sort of strange thing going on with the installation. But let's go back to 16 by 24. Although it could be that it's just a little bit buggy. I'm try this. Sometimes all I do is I'll just sort of close it out
Okay.
and open it up again, and sometimes that seems to help it. It's definitely a work in progress, but let's see if we can make it work. We'll say open. And where did you put yours?
It's in desktop.
That's up?
Yes.
Okay. Okay, so we'll see if we can get to that end again. Sorry. Okay. And in this case, it looks like it is finding it. So all I have to say about that is it's buggy.
Buggy.
Okay, because you were over here. So again, let's go fix 12 by 48. So now as we go through and we run, hopefully the points are showing up. So we're getting a list of instances and we're going downstream. I'll say no, it's definitely buggy. So if you're having that trouble, please go ahead and if your list is empty or you can't find the family type, just go ahead and close it back up and let's reopen the script.
All right, thank you.
Oh, no worries. It seems like a lot of people are sort of struggling with that, so let's go ahead and get it going through everybody. Okay, so let's see if you guys can get to the point where you actually have the list of all the different, you are returning the list. You doing good? Got back over here? Okay. If you do get a list, okay, then we get a list of XY locations. All this function does, XYZ X and XYZ Y, is it just pulls from that XYZ array, just pulls the X values into a column and the Y values into a column. So as opposed to looking like a column of 3 numbers over here, this should look like a column of single numbers, just pulling the X values and just pulling the Y values. And the reason we wanted to do that was I just wanted to grab the X numbers out so that I could go through and do this little sine function to them. I wanted to just use that as the basis for computing really what the height should be. So I'm grabbing out the X values, and what I'm doing is just really walking it through 3 different steps here. I want to do something that's like a sine wave, but the problem with sine waves in a lot of kind of applications is you have to kind of worry about the fact that they go up and down. So when you're determining heights, we have to do a little bit of adjustment to the whole thing. One thing we want to do is I set this notion of a base height. So that is, I want to do the sine wave, but don't just do it based on 0, because 0 would not be a good basis for the window heights. So instead, give me a base height somewhere up here, like in this case, like close to 8. Okay, and let's let the wave kind of undulate around that point. So that's what this base height is. But before we get there, what I'm doing is I'm doing a couple different things. I'm amplifying the wave, because that wave can look like this. Or that wave can look much more pronounced. That's what this whole amplitude is. So we're just going to multiply it with sine values by something there. The other thing that we're going to do is, though, it's kind of interesting to sort of introduce the notion of the wave frequency. That's really just, from here to here, measuring one cycle. So, yeah, if we go through and we bring that number down, what happens is you get a tighter wave versus a very loose wave. Okay, and based on how our X values are, kind of the tighter that is, the more you'll see a very clear wave, as opposed to kind of one where the frequency is very long, it may be harder to detect the pattern. So that's all that's really going on here. So it's really a little, multiply, compute the sine, kind of do something to the amplitude, and finally add a base. But out of all that, you get a new list of y values. Y values that have been shifted up and kind of scaled. And out of all that, the idea is, at the tail end of all that, what we want to do is just take those values and set the family instance parameter for the height based on those values. Okay, so a lot of math in there, but the fundamental idea of what we're doing is pretty straightforward. Okay. This other thing I did over here, which is just go ahead and show me those XYZ points so I can see the geometry here in this window and draw a line through them. That's just, that's a helper. That's not really doing anything back in the model. That's just geometry to help me understand what's going on. So let's just kind of try this and sort of see what the effect is. I have run automatically turned on, so that'll just make it a little more straightforward. And right now, the line in the background looks relatively flat. That's because the wave amplitude is set to 0. So if you just try shifting that around, go ahead and take that wave amplitude and give it a little nudge. Okay, you'll see what you're seeing down here on the bottom is this is all these lower blue dots down at the bottom. Those are the dots that are indicating the x locations, and the lines going through the y locations that are all amplified. Yes.
So you're extracting the location of the windows from the other slide.
Yes.
So I was wondering, is that like the center of the window, or is it?
That's a very good question. I think it's of it as the base point of the window. Every object has a base point. So even when we look at the family, there's like this little crosshairs location. So I think it's that. We can test that. In fact, we're going to go through and edit this window in a little bit. And I think you'll see exactly where it is. But yeah, it is, although it's interesting, let's try that too. I'm kind of curious about where the z is. I understand where the x and y would be, because they're sort of typically a little crosshairs when you're placing them in the plan. Let me just sort of see what the z's are right now. Okay, I guess that is, because the base height is now 7.9, these are all reported at 7.938. So it looks like the z of a window is the base of the window. So if I was looking at the window in elevation, okay, the x and y is determined by the center line of the window in plan. Z is being determined by this base height. So that's where the x and y are coming from. But that really depends on just how the object is defined, because everything really goes relative to what they call the insertion point. So I guess this is moving the insertion point around. Okay, we'll try that, see if that makes sense. Okay, so the amplitude, you sort of get the effect of that. Base height, you ought to be able to kind of see the effect of that if you want to just drag that down or drag that up. And what we have to watch out for, it's just this notion, well, actually, windows aren't so bad. Windows can be placed so the lower boundary is lightning. That'll work. Windows can sort of have to be hanging in walls and half outside of walls. I guess where that gets to be really important is when you're creating a solid sometimes, you can't have negative height to it. So watch out for that. The other thing to watch out for, let's just check the effect of this wave frequency. If you try sort of either making that very tight, you'll see you get sort of a relatively smooth curve in the background. If you make that very kind of far, what happens is just because the spacing of where you're evaluating the points on the curve is very, very far, you just don't get as much of a smooth curve because, if it's very, very tight, I'm getting that point, I'm getting that point, I'm getting that point, I'm getting a lot of points that are very, smooth. You can sort of really see the pattern. When it gets very far out there, it's just harder to detect those patterns. It's because, you're sampling, you got that point, and this point, and that point, and, it's very scattered, so it's hard to tell what's going on. Let's go ahead and try building this up. Because this is kind of the finish, putting it all together with that basic algorithm or that kind of design in mind. Let's instead go ahead and open up. the starting point file, and let's see if you can build it, because it's not too bad. I put some of the basic elements in here to help you. That's really zoomed in very, very tight. Gonna pan that over so you can sort of see. And let's see what we started with. So it all starts back over here with the select family type and grabbing a type and getting those family instances. That's okay. And even this part over here, getting the X and Y values. We're doing pretty good over there in terms of giving you those nodes to start out with. But let's go ahead and just start linking the rest of it together. So we got the instances, we got the locations. These two functions go ahead and pull off the X and Y values out of that list. And now we're ready to start doing all the multiplication and just really trying to make this the sine wave that it wants to be. So we could go ahead and just grab those X values and connect them directly into the sine function. Okay. If we want to apply that little frequency, what I'm going to do is just multiply something by it and then connect that into the sine function instead. Okay, so why don't you go ahead and follow along and see if we can kind of just put this all together where, oh, for this, doesn't really matter the order. I could have actually hooked that up to that node of it instead. I'll hook that one over there. So that's just going to multiply those two values. So let's kind of see if it sort of makes sense. I have a value over here of about, oh, let's say, in fact, I can even type in, I want to put a value in there of 0.5. So in theory, as opposed to negative 19.79 and or negative 17, negative 15, I would expect to be getting negative 9.5, negative 8 something or other, negative 7.5. And so that list looks like it's functioning the way we want it to. And these little pop-ups that show you the previews are very, very useful for debugging this stuff because you should be able to follow the logic of what's happening to the numbers as you go on through. Okay, as we come popping on through here and connect that into the sine function, you'll see this is starting to give us that whole, oh, it's jumping up, it's jumping down in terms of positive 0.45, negative, 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 positive, and they're ranging anywhere from -1 to +1. So just based on that X value, it's returning the sine and giving us these values between -1 and 1. Then we want to go through a couple different things. We want to scale those values up so it's not just -1 to +1, but it's actually a broader range. And we also kind of want to put the base height into that. Okay, so let's hook those pieces together. We'll just give it the amplitude. Now, to apply the amplitude, I want to do a couple different things. I want to basically take that amplitude and multiply it by the sines. So it's going to use a multiply function. And then I'm going to add in the base height. So go ahead and do that if you can. Let's just add those in. I'll do it too as we go. I'll just give it the multiply. So multiply always just takes two different values, strings them together. Now in this case, my wave amplitude is set to 0, so I'm going to get a bunch of zeros right now. I need to go ahead and change that up a little. Okay, and we're getting a little bit better. But again, these are ranging. Now it's from close to -3 to +3. That's the amplitude I apply, but I need to sort of get that offset to kind of keep them all positive. And I think as Hong pointed out a couple times ago, we could do an integer slider if that makes it feel better, as opposed to doing any number. You can control that if you want to have whole numbers as opposed to having infinite flexibility. We'll add those together. Okay, and now, theoretically, we have a bunch of values that should be a pretty good set of values for the y's. So going anywhere from 9.4, 6.45, kind of veering plus or minus 3 around 8 is really what it's saying. Okay, and finally, we're just trying to go through and use those for the sim height. So The sill height right now is currently set to just 5 because of this slider. That's the value right now for everyone. If we want to go through and replace it so the sill height is not determined by this number, but instead comes out of this function, all we need to do is link those two together. So let's see if we can make that work. I'll just drag that over here. I'll replace that value, and we're kind of okay. Now, I'm learning a lot about Dynamo in terms of different ways of playing around in the interface. So I'm going to share just little things I've kind of stumbled across. Oh, copying and pasting works very well for kind of repeating nodes, renaming the nodes. You asked about kind of putting the notes in. That's all very good. Yeah, it's very good to document this so you can sort of see the logic, because these networks can get very, very complex. If you want to unhook a node, what I've been tending to do is I just kind of click on that again and just hit the escape key, and that sort of unlinks things. You have to kind of drag it off to somewhere. There's probably a quicker way of doing that. That's the way that I've been using. Okay, so theoretically now, using all these values, we should have a whole series of these different instances that are all going to adopt that value. Okay, and this slider at this point is irrelevant. Doesn't really matter to us, but we can keep it around. It's not hurting anything. Okay, if we go back now and look, okay, hopefully it's looking pretty good about what we want. And if it is looking pretty good, kind of scooch that over a little bit. There's never enough window space for what you want to do. You should be able to do things like, if you adjust the base height, the whole wave will either go up or down. If we adjust the amplitude, okay, the degree should change there. And this is the one that always fascinates me. It's this frequency thing that somehow a very tight frequency gives you what is very clearly a curve. Whereas, just based on sampling, even though that's all determined by the curve, it doesn't really appear to be. And it's just because of the way the things got put in there. But if you're trying to create some very cool artistic effect where you want to be able to generate these programmatically, I don't see repetition of the curve here. I do see a little repetition. This is kind of happening further out there. It's still a lot easier than trying to place them all out automatically. Actually, it's very, very hard to just place things manually and make it appear random. It's inherently kind of a hard task. Okay, so this is this whole notion of just like setting a single parameter, the base height, based on that. And that's kind of okay in terms of what's going on. Let's pause there for a second and just kind of think about that in terms of what that does and think about where we want to take this next. Because being able to set the base height of the window sounds pretty good. Yes? Is it making sense, or what do you think?
What's the meaning of F5 in the set family instance parameter?
Oh, okay, so in set family instance, so back over here.
What's the meaning of Fi?
Okay, Fi is a family instance. It's weird, these are all, this is the parameter value, or this is the parameter that we are changing, the last one's the value. So Fi, family instance, the way to look at it is we have to go, if I bring it back over here, it ties to the instance over there. Often when you hover, it'll give you a little guidance about what it is, but it is all these little very short, of course you know what it means, because you know what it means. Once you know what it means, it's perfectly obvious. But before that, so even here, after we've set this family instance, we could take this off and do some more with it. The modified family instance would be the instance that already has this transform applied to it. Let me go ahead and change some other values on it. Okay. If there was a kind of a chain of dependency where you want to change one thing first before you change something else, because in this there's not a whole lot of like time logic in terms of it'll all try to resolve. Unless you try to build in an explicit time dependency about change this first, then change that. So changing a single family instance is kind of an okay thing in terms of what's going on. But if I think back to, what even CJ was trying to do with his example, I think it was actually a little more, there's more we could be doing with this. And that's what I want to explore next. Okay, let's do this. Am I running? That's my frequency. That's good. Over there. Okay, let me just kind of button down the amplitude a little. Okay. As we think about placing windows like this, there's a lot of things we can do to go through and think about adapting them and really being able to adjust so that they're responding smartly to the position of the sun, the side of the building they're on, relationships with other objects in the model. So there's this whole notion just of the height of the windows, but there's some other parameters we can try changing too. For example, we might want to just try changing the size of the window, not just the base, but the height and the width of the window. Okay? Another thing we can try changing is these windows are all just fixed windows. They're kind of okay, but not very interesting. If we want to start thinking about some sort of a solar shading strategy, we can think about having shelves that are at the top of the windows or at some height on the windows to shade things. We can think about fins on the sides of the windows and also adapting those. And within those different things, we can think about just adding them, having a shade or not having a shade, having a shelf or not having a shelf. Or we could go through and even think about adjusting the depth of those things. So we start getting smart about that. It's really, you have several different types of parameters to play with. You have sort of whether something exists or not. Okay, is one parameter you can change. Then you have all the dimensional properties. You can start changing those. And that's where it starts getting interesting. Because you could sort of imagine, based on sort of some aspect of either how the building's oriented or where the sun's going to be, having shades that are different depths depending upon how much sun's going to be, they're going to be exposed to, or some sort of effect trying to create different sort of fins, turning them on, turning them off. You can really get all sorts of undulation. You can change the height of all these different windows. There's a lot of things we can do. So what I want to do is actually take a look at that window object and back up a little bit and say, hey, the fixed window's okay, but if I really want to get customization, how do we add a whole lot more customization into that part? Because part of what we're doing is, you get the power out of making good parametric parts, then you get the power out of being able to control the parts. So a big piece of it comes with just starting with making better parts for yourself. So this is what I want to do is head down the whole notion of, can we make smarter parts? And in terms of doing that, well, let me go ahead and just open up a file and kind of show you what I have in mind. So let me close up Dynamo for just a little bit, and we're instead just going to go into the Revit family editor and take a look at those and do some adapting. So I'll say no to that. So for any of these windows, you can just say edit the family, and we can go back and see really how it's defined. And here's this little window, this 12 by 48 window right now. And we can go through and see what sort of parameters are available. You'll see there's all sorts of parameters. There's height and width, things like that are type parameters. There really aren't that many instance parameters here. Okay, as I look at a default sill height, okay, that's an instance parameter. I'm going to pop that over. Actually, no, sill height is. Where is sill height even in here? It's the default sill height. Oh, it starts out being placed there. Okay, never mind. Windows do something funny when they actually go into your building. Okay, but if we wanted to go through and start changing those, for example, if we wanted to be able to have windows where we could programmatically change the height and the width very quickly on a window by window by window basis, as opposed to doing it by types, that's actually pretty easy to do. What we want to think about doing is just changing these parameters from being type parameters to instance parameters. Then we have the individual control. And how you do that for Windows anyway, which is a little bit different than a lot of your other families, looks something like this. If you go to the floor plan that defines it, you'll see actually there is the base point where we're really getting the locations. It's right here. It's the intersection of what's considered the front back, or the left right and the front back center points. And even in this, there's this funny thing about defining the origin. Let me try back over here. Not showing it there. Interesting. That is the center point left right. Okay. What happens in here is there is, for example, a width parameter right there. And if you want that parameter to be an instance parameter versus being a type parameter, all you have to do is click on the dimension and you actually get the choice. width right now is 2 feet. It's not an instance parameter because that's not checked. If we want it to be an instance parameter, we just need to check that. So you can check that. In the same sense, if I go over to the elevations, take a look at how this window is defined over here. You sort of see there's default sill height, there's the height of the window. If we want to be able to change them programmatically, we need to make that an instance parameter. Okay, and that'll get us the first step of the way. So if I say, let's go ahead and make that an instance parameter. Super. What'll happen now is you'll see they say height and width by default. Okay, 2 and 4. Okay. But now we can go through and start using this and changing that a little more programmatically. So for example, let's go ahead and do that. Say OK to that thing. It is very useful now that we go through and we're making a bit of a change to fixed RFA to save that away under a slightly different name, just so that you know that it's not the standard one. So what you might do is do a save as. It's going to be a family. And I'm going to go through and put them out there. Okay, fixed. Okay, with what instance. I'll just call it adjustable. It's easier. Save that away. If you load that back into your project now, and maybe I'll grab all those. Actually, a quick view if you want to change them is, let me say, I take that back. I could place one to this smart, or yeah, kind of sensibly. I'll go window, there's fixed adjustable size, so I can drop that thing in there. Okay. If I want to replace all these existing ones, what I can do is, well actually, I'll do this better. Because it's there, I can now adjust the height of the width independently. Okay, so we have that sort of individual control over that window. If you want to actually go through and replace them, what you can do is just come through, and if you choose one of them and right-click on it, you can say, oh, let me say select all instances, either in the project or just in this view, but I can grab them all. And then I can get that adjustable size window. Okay, so now these are a bunch of 12 by 48s, but the height and width are adjustable. Okay, so now we can actually go back and change our logic a little bit. If instead of going through and having the base heights widths controlled, okay, if we want to actually have the height of the windows controlled, okay, no worries. What we can do is go back. Let me get rid of that one. It's kind of hanging out there in a funny way. Let me open up that script again, and we'll take a look at it. We'll say add it. Open that up. Okay, let me get the endpoint one. Let me just set them all back to where they were in the first place. And I'll do that by giving them the wave frequency of 0. Well, actually, this is interesting. I already changed them, so it's not going to work exactly. Okay, now as opposed, actually, it's interesting. It did adjust. It swapped. I'm quite surprised it did that. So it was basically the fixed size window, and it actually adjusted it so it went to fixed adjustable size too, which is actually pretty good. So grab me the list of all those. In theory now it should be grabbing the whole list of those. Okay. And now if instead of, I'm going to change the amplitude down to 0, great, that's all fine. Let's take a look at what's happening in the background. Hopefully they're all looking about even down there. Super. So if instead of changing the base height, now I want to make that to adjust the height parameter, all I have to do is come back over in here. And for these, instead of sill height, let's just change that to height. Okay, again, it's going to be dependent on really whatever you have listed in the instance parameters. It's just name dependent. So if there's not a name batch, it'll turn red and complain at you. Okay. In this case, it seemed like it matched. Let's see what's going on there. That's interesting. They're all the same. Oh, that's because right now the amplitude's 0. So that's why they look like they're so flat. Let me kind of bring this down. The base height, I guess you'd call that almost like the minimum height of the windows. Okay, so if I start giving that an amplitude, let's see what happens back over there. Okay, now I have waving windows as opposed to just waving sill heights. And that's kind of like what CJ was trying for, something like that. Okay. So the idea behind this is really, we can really make any instance parameter available. We can make the height, we can make the width, and that part's all cool. But what I want to show you is that you can actually start building some very smart objects too. Okay, so it's really cool you get these objects, but what if we actually wanted to go through and start adding a shelf and some fins to this thing and have that respond very smartly? And it's kind of really this the next level of making smart parametric parts. And what we're going to look at to do that is actually combining parts together into like macro parts. Okay, and that's a really useful thing to do. Because when you start doing that, you can start building up assemblies of a lot of little primitives. Okay, and kind of make much smarter pieces that you control just as one. So let's kind of take a look at how you do that. So I'm going to go back over to, in fact, if you want to start over, you can open one if you want to, if you don't have that same kind of part saved from last time. What I'm going to do is just come on out here, session 3. I happen to have in that folder for you some parametric windows and parts of windows. And it's really just sort of a progression here of different things where I kept on adding complexity. We started with window fixed. And then we actually created window fixed adjustable size. That's just kind of making the height and the width parameters available to us. And then what I did was actually created a couple different other pieces. I created a shelf of adjustable size and actually created a fin of adjustable size. Let's talk about that and how you get them all together, because that's really where it gets interesting. So I'll start by just getting that window fixed adjustable size. This is where we left it last time. Okay, it's hanging around over here, but the height and the width are adjustable. And what I would like to do is actually go through and create a shelf now and a fin. And it turns out that's going to look amazingly similar in terms of what we have to do. To do that, what I can do is actually, I could put it all just in this single window, but I'm going to be strategic about this and actually make my shelf as a separate type of family, because then I can bring that shelf into a lot of different window families. I don't have to kind of keep on redefining it. Just the primitive of a shelf would be a pretty good basic thing to have that I could put into a fixed window, into an operable window, any kind of window. So to do that, what I'm going to start by doing is just creating a new family, and then we're going to put them together. So in terms of the new family, let me come back out there. Let me just say that as a starting point, we'll go ahead and make it just a generic model. Although I could put it in any category I want to based on just really how I want it to appear with visibility graphics. And the way you define this could be a little bit of review for about the next 4 minutes here, but hopefully this will all work. This is the base point. We have the front back center, the left right center, and it's this whole notion of what we did as part of 120A, just creating different reference planes that could then control geometry and make everything fit. So what that looks like is, if I, for example, want to go through and create the shelf, I want it to have like some distance to the sides of the shelf. I want it to have some depth to the shelf. So what I can do is, just set up some reference planes that are going to be the left and right sides of the shelf. I'm going to set up a reference plane, which is going to be the depth of the shelf over there. Okay, and now we go back and do that thing that we did in 120A where we use the dimensions to just go through and control those. Where I can say, hey, I like these. What I would like to do is take those two sides and always make sure that it's an equal relationship so it always stays balanced. Okay. I'd also like to have a dimension which can control the total there. And I can call that dimension there something like a shelf width. Okay, and I'm going to make that an instance parameter so I can change it on a basis, a window by window basis. Because if I'm going to attach it to windows that change, I'd like it to be able to change quickly too. The next thing I'm going to do is create a dimension that goes from this insertion point back to here. Okay, and I'm going to call that guy my shelf depth. Oops, not shelf width. Add parameter. Okay. Looking a little odd right now. Let me make the shelf depth something a little bit easier, or easier to see. Okay. Now we're ready to start creating some geometry. So I'm going to create an extrusion that's going to fill in that and hang on those sides. So to do that, I'll say create. And what I do usually is, since I'm cautious about making sure things really link, I'm going to draw the geometry just inside. I should have just done that as a rectangle. That would have been simpler. And I will then do some aligning. I'm going to align this to that, lock it, this to that, lock it. Oops, wrong way. Okay, and hopefully now I have some little piece of geometry that's going to adapt when I go through and change those parameters. Let's take a look and see if it does. So I got this little piece of geometry. Oh, in theory, when I say that wants to be 1'6", with any luck, it'll become 1'6". If I say that it's going to be 6 feet long, it'll do what it's supposed to. Okay, that's not looking too bad. We have the beginnings of a shelf here. It's responding in 2 dimensions. The other dimension I want to respond to is just the thickness in terms of the shelf. It's a little bit chunky the way it is right now. So to do that, what I'll do is go to the elevation view. And I want to do that same sort of thing. I can either say that the shelf is just going to be based on a reference level and come above, or I can say it's going to be centered on the reference plane. It's really whatever way you want to go through and define it. Yeah, I'll put this one. I'll put a little plane above. I'll put a little plane below, kind of on the assumption that I'm going to be centering it wherever I insert it. Do those same sort of things about, oops, annotate. Taking these dimension lines and saying I always want those to be nice and equal. And then I'm going to take this one to that one. I'm going to call that the shelf thickness. Still sounding familiar? Remember all the stuff from the old 128 stuff? It's been a while, but you were trying to forget it, but it came back to haunt you now. Okay. And then with this, we can now go through and just lock the geometry to that. So I can align this to this, and I can align this to that one there. Very good. Okay, so with those 2 pieces in place, we got the top and bottom, and we got, always just remember what connection's going. We should hopefully have something that's looking pretty good. Let me just kind of test this and flex it a little bit. I'll say the depth is 0.2, or thickness. I just have to keep track of like what you think of as the way you talk about these things. With any luck, we have some groovy little 3D shellfish thing. Sound pretty good? Okay. The next step in putting this all together is say, hey, I got a fantastic shelf, I got a fantastic window. Can I get those 2 things together and get them operating smartly with each other? And here's the general overview of how you do that. Let me go ahead and save this out. I'm going to say this is going to be my shelf. Adjustable size. Okay, so I got to get my window and my shelf together. What I do is I come on over back to my window, since he is going to host the shelf.
and I bring them together. So here's what I do. In the window part, okay, I can actually load in the shelf part and then kind of hang them all together. So what I can do is say load a family. I'm going to go out there and grab that shelf that I just got. Where are they? In there somewhere. There's my shelf. It doesn't really pop in. It's not quite sure what to do with it yet. I'm going to pull it in. There it is, kind of hanging out. Okay, so here's what I need to do now. I need to get my shelf and I need to get my window together in terms of how this is all going to work. There's a couple of things that are going to define its relationship. The back edge of the shelf should probably be the front edge of the wall here, something like that. That makes sense to kind of lock those together. So, or you could put an offset in there. If you had some little bit of a, whatever, some kind of offset you want to put in there so it stands off there, that's super. Okay, but let me try just aligning those. I'll say align this to the back edge there, and I'll lock that together. Hopefully that'll stay together. Another thing we'd like to do, I'd love the center of my shelf to always line up to the center of the window. So how do I do that? I can say, let's grab the center of the window. Let's find the center of the shelf. And I'll lock those two things together. Okay, so now we got those two things together. We're doing pretty good. We just need a couple more things that will help us out. Okay, we would love to have the width of the shelf either match the window or maybe be a few inches, whatever the relationship is we want to have to it. Okay, I'm going to just match it to the window right now. And you can think about how to do that. Here's the part that you may get yourself in trouble in, but don't overthink it and it'll kind of work. If you have a parameter set up for the width of that already, or okay, for that distance right there. So what we want to do is, as opposed to just locking it to those dimensions, use that parameter to your advantage. Okay, so here's what I mean. So over here, this shelf, okay, it is an object, it has instance parameters. We can actually create a formula that relates its instance parameters into the values that the host has. So shelf width over here, right now it's currently set to 6. I'd really like it to be 2. Okay, don't lock it. What you can actually do is just say, I would like to put a parameter in here. I'm going to associate this value with the width of the window. And now what's going to happen is anytime the window width changes, the shelf width is also going to change. Okay. So that's where the trick to all this comes, is go ahead and you almost have like this tunnel that goes from the highest level to the lower level and the smallest level, and you can really stack these quite deep. And what you have to do is basically just connect things together from one level of the hierarchy to the higher level of the hierarchy to the highest level of the hierarchy. Just keep on linking them by the parameters and it'll all stay in good shape. So that's how we can handle the width. The width actually works out to be pretty easy. Just the width of that shelf is the same as the width of the window. That's super. Okay, and you think we're going to be in pretty good shape now, okay, in terms of what's going on. Because it seems like, well, I got a shelf thickness, I got a shelf depth, I have all these different things. Yeah, we ought to be in pretty good shape here. Okay, let's go ahead and save this, and we'll put it in the model, and we'll see why that's not quite right. Looks like it just saved. Okay. Let me load it into the project. I'll load it into my little sine wave project. Sure. There they all are. Okay. The widths are about right. Okay. Now there's still looks like I didn't pay attention to the height. I gotta pay attention to that in terms of what's going on. Okay. The other thing you'll notice about it though, that it's sort of missing right now, is when I go clicking on this window, okay, I still get the width and the height. What I don't do is I don't get direct access to the shelf's parameters. I have access to the assembly's parameters, but not the shelf's parameters. So we have to actually put a little tunnel in there to give us the ability to go through and do that. Let me show you what I mean. Okay, so let's go back over to the other one, this little assembly that we're putting together. Okay, boy, I thought I was doing good until I checked out what's happening on the floor there. Let's see if I can find it over there. Where'd it go? I think it's on the exterior. Am I looking at the right one? Nope, it's not the right one. Okay, let's try again. How about this one? Fixed adjustable size, window fixed adjustable size. Is it that one? No, I think it's this one. It helps if you're not so scatterbrained about actually organizing and naming your files. There it is. Okay, there it is lying on the ground. Okay, so should have checked that. If I want to fix that, here's how I can do that. I can go through, and if I go to the exterior elevation, see if I can take a look. It's hanging around over here. What can I do? What I want to do is basically go through and kind of create some sort of association. I have the shelf width, thickness, depth, stuff like that. Oh, if I want to go through and pull that thing so that, for example, it matches the top line of the window, all I need to do is, that I would actually probably put in as an align relationship, just lock it in there, because I didn't actually put a height on the shelf. I could have put a height on the shelf versus the baseline, and I'd have more control over it. For now, I'm just going to lock it to that level, but it's just really a question of whether I put the parameters in. So what I'll do is I'll say, let's align from the upper level there to this guy here. Okay, hopefully that's looking pretty good now. As always, let's test it. Let's test that window, and if that window just happens to be instead, oops, I have to do that there. If that window turns out to be 5 feet tall instead, okay, shelf seems to move. Okay, that part's pretty good. But here's the deal. Although that shelf is hanging around there, it looks like it's pretty good on the width that's picking that up by association. Okay. The thickness and the depth of it is not available to us yet. And what we need to do to make that happen is actually pretty straightforward. What we have to do is, let me say okay there, is for the shelf over here, I connected the width into a formula, which is associating with that parameter. If I want to make the thickness and the depth available, what I need to do is actually just create a parameter in the assembly that will pipe a value right on down here. So, for example, on the thickness, or let's do the depth first. Okay, I could associate it with any of these values that are available, or these parameters that are available in the assembly, but there isn't one for it right now. So what I'm going to do is actually just add a parameter to the assembly called shelf depth. Make it an instance parameter. And what that's doing is saying that you can type in shelf depth in the assembly and it'll type it through to the part and kind of make it, change it there. Notice that when I do that, it becomes gray, there's a little equal relationship there. At this point I know it's controlled by something else. It's not controlled by selecting the part. What it's controlled by is, ooh, there's this value over here. So if I change it over here, it'll change it. So you got to think about the hierarchy of parts and how the relationship between all the parameters really allows them to flow through. So let's say we do the same thing for that thickness. So right now, thickness is not a value that's available to us for the assembly. Okay. It's only available for the part. So we're going to go through and grab that little part. Say shelf thickness of 0.2, that sounds fine, but let's make it available in the assembly. I'll say add a parameter, call it shelf thickness, if I can spell. I'm going to again make it an instance parameter, so I could change that, but I don't necessarily have to. Okay, and now over here, in terms of the thickness, oh, I could go through and change that. And it'll get thicker or thinner just as it needs to be. Let's make it so let's roll on back to the whole issue. Why are we doing all this? The reason we're doing all this is by putting all this instance parameter control, the height, the width, the thickness, the depth of that shelf, we're starting to create a single smart object that now has the ability to control it parametrically, the ability to script the behavior. So as we rotate this around and put it in different places in our building, we can then start to control it based on proximity or sun location or orientation and be very, very smart about it. Okay, there's one other instance parameter I'll show you about before we go to the break. That's actually a really useful one, and that is just whether or not something should even exist. Okay, because what if I want to have this smart window, but on some windows I just don't even want to have the shelf. I just want 0 in there. Okay. And for this guy, there actually is a notion of whether or not it's visible. So if you want to have that as a variable that you can control, either make it visible or don't make it visible, okay, you can just turn this value on and off. Okay, it doesn't appear to do much in here because it still shows it to you. When we put it in the family, it'll kind of make it visible or not. But if I want to let visibility be one of the parameters that's available, I again make it a parameter, and I'll say add a parameter to this. It's going to be called shelf visibility, or shelf even being there, existence. It's really probably a better way to look at it. Say OK to that. Okay, and now it's over here too. It's down in the other section right now. Okay, but I can turn that on or off. So let's just test what we have so far, then we'll go to the break. I'll say, let's load it into the project, take it over to that window sine wave. That should be fine. Okay, so we've got all those little guys kind of hanging around. Looks like they're doing a pretty good job of still following the sine wave. That's not too bad. Now, in terms of being able to control any individual one of them, you'll see that it has shelf visibility. So I can turn that off if I want to. That one has no shelf. Or that one over there has a shelf which is going to be 1 foot deep. Okay. But now I'm starting to have a pretty smart object that all of a sudden I can control the height, the width, the height of the window, the base height, this whole notion that the shelf exists, how far out is the shelf, how thick is the shelf. Okay. And when we come on back, I'll show you the final version of this part, which actually includes fins on the sides. So you have this all-purpose, handy-dandy, pretty much any window condition. You can turn things on and off to go ahead and make it what you want, which we'll then use to smartly control. Okay, but let's go ahead and